Hi, hello, welcome to this channel. Today we are going to see about circular convolution method. This is an important topic in discrete time signal processing. So we are going to see what are the methods. It has three methods: concentric circular method, matrix multiplication method, and DFT technique. DFT technique is nothing but discrete Fourier transform. So we will be having our x of n. We are going to find the x of k and then doing a circular convolution. We shall move. So first method is concentric circle method. As the name indicates, you will know what we are going to do in this method. Just we are using concentric circles here. That is, if you are having the sequences which is up to n number of sequences, you are going to take n number of concentric circles according to the sequences. So see here, x1 is going to be one sequence and x2 is going to be another sequence. We are having three samples in each sequences. So the first x of n sequence we are going to take as the outermost concentric circle. You can see the size comparing to this, and this is our innermost concentric circle. So x of 1 is outer and x of 2 is inner. There is a slight differences more than the size within these two sequences, which is the allocations of those samples. So x1 will be plotted as clockwise direction and x2 will be as anti-clockwise direction. Here we have indicated the direction. So clockwise is here in this direction as said above, 1, 2, 0. So 1, 2 and 0. Here as it is anti-clockwise direction, 3, 5 and 4. So this is our anti-clockwise and this is our clockwise direction. Now you just merge this smaller circle, concentric circle, into this larger concentric circle. Then just multiply the meeting numbers. So in each side you will be getting a meeting number. The both x1 of n and x2 of n will be meeting then and there. Just multiply and add them. 1 into 3 is going to be 3, 4 into 2 is 8, 0 into 5 is 0. The whole value comes as 11. So this is our output for y of 0. So indicated here y of 0. Then we are going to see y of 1. How we are going to find y of 1? It's very simple. You are going to shift, that is circularly shift the x2 of n values in clockwise direction. In this direction you can see here 3, 4, 5. If you shift it clockwise, it will move here. 3 moves here, 4 moves here and 5 moves here. So see here 3, 4, 5. So 3, 5 and 4. This is the shift. This is a circular shift. Again you multiply. 1 into 5 is going to be 5. 2 into 3 is going to be 6. And 4 into 0 is 0. So 5 plus 6 is again 11. This is a y of 1 value. Then we are going to see about y2 value. Again shift it. Second spin. We have given first spin and second spin. As this n value indicates the number of spins. So just spin it around again. So 3 will move here. 3, 4 and 5. Actually we have to mark 3, 5, 4. But for your understanding, I am just marking 3, 4, 5. It's just shifting from here to here. So this is an circular convolution. So we are going to get 4 into 1 is 4, 5 into 2 is 10, 3 into 0, 0. So 4 plus 10 is 14. So how you are going to represent this? Just y of n. Y of n is equal to 11, 11, 10, sorry 14. So this is the y of n value, output for the given two sequences. Are you clear? Then we shall move to the next slide, that is matrix multiplication method. I used to use this method regularly for those to find circular convolutions, because it's damn easy. It's very simple. They have given x of n sequence and h of n sequence. We are having 4 samples and here also 4 samples. Let me explain. It's very simple. This is a y of n, that is nothing but our output, and this is our input values y x of n, and this h of n, how it is depicted is nothing. Just do as if you are having h of n values as so many samples. For example, n samples you are having, just continue as 0, 1, 2, 3, 4 up to n. If h of n is going to be your last sample, then take this last sample as your first sample. Clear? So this sample as your first sample. Again, just continue with it. If this is your first sample, then again this is your last sample in those given sequence. Just add it in the top and then continue with the remaining. As this is the last sample, your first sample will continue from here. So again 0, 1, 2, 3 up to n minus 1 it comes, right? N minus 1. Again take n minus 1 as your topmost sample. So just go on like this. So here n minus 1 is 2. Again I am continuing the sequence. I am having 3, 0, 1. Again taking 1 on the above. So 1, 2, 3, 0. We should not take again 0 to the top because we are having this sequence already in the first column. So each column start with the last last column. Okay, last columns first rows last column, last rows first column. Okay, whatever it is. Then okay, this is going to be our matrix for h of n. Just substitute. H of 0 is 4, h of 1 is 3, h of 2 is 2, h of 3 is 2. Again go on substituting those values and multiplied according to the row and the columns. Then we will get the matrix value. Okay. So you take and write the matrix value, that is going to be your output y of n. So this is the easiest method, matrix multiplication method. Then we shall move to the DFT technique, discrete Fourier transform. So here they have given, again we are getting two sequences, x1 of n and x2 of n, each having 4 samples. In this you should count the number of samples. So first we should know the length of the samples. So length of x1 of n is 4 and length of x2 of n is again 4. So the length of circular convolution will be maximum of these both length of x1 of n and length of x2 of n. So if you are having only 3 here, then the answer will be 4 again, because the maximum will lead to the length of the circular convolution. So this moves as if, okay, now as the title says you that it is a DFT technique, you are going to find DFT for each sequences for x1 of n and x2 of n separately. So we know how to find the DFT. Just output x of n. X of n is equal to, that is actually it is x of k is equal to multiplying the twiddle factor along with this is trivial factor would be n and kn into the value of x of n. So I hope you have seen the previous videos about the trivial factor for n is equal to 4 and n is equal to 8. We were actually this is going to be the important thing, because you have to learn the trivial factor each and every time. You can do the derivations, so you should have a hint how to write our trivial factors. Just remember, the first column will be always 1, and accordingly we are going to use only one value and j values. So let it be, just take, if you have not seen the video yet, just go through. I'll say the easiest method. Take a circle, divide into 4 quadrants, let your y-axis be imaginary and x-axis be real value. Okay, so this is bi and this is 1 and this is minus I or j, whatever it is, and then this is going to be minus 1. Just do as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So whenever, just do a matrix value, because this 9, 5 all indicates the value for kn. Just substitute those values in these, because you are just going to actually for this part you will get w4 to the power 0 for all these two rows and columns. You will be get value w4 power 0, so you are getting us 1, 0, all 0, actually 0 is here, so we are having 1. So just compare those values and substitute the values. You will get this beautiful twiddle factor. Then you multiply with x of n. As usual, it's a matrix multiplication. You will get this value. Again, as same as x1 of k, it's going to be x2 of k. Again, take the twiddle factor, multiply with x2 of n, and you will get another matrix. Now we are going to multiply for the final output y of k. You are going to multiply x1 of k and x2 of k. So when you multiply, you will be getting your value. So again, we don't need for y of k, right? We need y of n. That is our output. In every method you have seen, we are finding only y of n. So we not need any y of k. So we are finding inverse discrete Fourier transform of y of k. It's very simple. It's very simple. Just multiply 1 by n. Actually this format is 1 by capital N. We are finding for n is equal to 4, because we are having n number of samples. So we are having 4 number of samples, right? So we are taking 1 by n, that is 1 by 4, into the twiddle factor yn of kn into x of this is going to be y of k. Okay, so this is what you have found in the above. So just multiply it, you will get this answer. So this is going to be our y of n value. Okay, y of n is equal to 11, 9, 10 and 12. Thank you guys. Please subscribe this channel